Let's revisit our CalcEngine demo. And now we'll actually add arrays and a loop so that rather than processing one value at a time, it can process multiple values. We'll also use a switch statement to take that complex if-else we have in there and make it much cleaner. To update our program to process multiple values at a time, what we'll do is we'll take each of these four declarations at the top and convert them into arrays. So we'll take the first one. So our first one there, val1, let's make that a double array. And instead of calling it val1, we'll call it left vals. And then we'll initialize it with, say, 4 values. So we have that. So now what we'll do is we'll replace val2 with something called right vals. And we'll initialize it with the same number of values. And now we'll have opcode. Instead of calling it opcode, we'll call it opcodes. So this will be a char array. So we now have each of those initialized with 4 values. And of course, we want to store those in our result. And we'll do that as an array. So we'll make our result a double array as well. In this case, I'm calling it results, plural, because it can hold multiples. Now, I don't want to initialize this one with a value. Right? I want to initialize it with space to hold the different results. So what I'm going to do is use the new and say double. And now for the size, I could set it as a fixed size of 4. But really, I want it to kind of be the same size as like opcodes is. So what I'll do is I'll just use opcodes.length. And that now sets me up with the results being the same size as opcodes. And what we have here is these 4 arrays are what we call parallel arrays. And that idea is that when you set up multiple arrays where the first value in each one works together, the second value in each one works together, and so forth, right? So we'll have 100 from left vals be used with 50 from right vals. We'll use the D from opcodes and then store that in the very first position in our results array. All right, so let's go ahead and comment out these other ones here, the old ones we're not using anymore. Okay, so they're all gone. So now what I want to do is loop through these values and use them, right? So because I'm using the same position from each one of these, I'm going to use a for loop where I actually increment an index. And I'll use that same index for each one of the arrays. Right? So I'll set up a for. I'll just say int I equals 0. I'll run while I is less than opcodes.length. And then I'll want to increment I each time. I want to include the whole if statement underneath here, so I'm going to go ahead and put brackets around that. Now I need to go through and update each one of these, right? So instead of saying opcode, I'm going to use opcodes sub I. So I'm going to compare that against A. And then of course result will be results sub I. And that's going to equal left vals sub I plus right vals sub I. I'm going to do the same thing for the opcode of S. Now when we get to D for the divide, initially that's the same, right? Opcode sub I. But now we want to just make sure that we change everything we need to, right? Because we actually check val2 as well as use it. So we want to make sure we make val2 into right val sub I throughout this whole thing. And of course val1 is left vals. And of course our result is results. All right, so now we have our result sub I equals right val sub I not equal to 0, then it's left val sub I divided by right val sub I, otherwise it's 0. Then we get down here to our opcode M. It's going to be just like it was with A and S. And then the last thing is just to make sure that our else statement uses results sub I. All right, so now we have our for loop here set up to go through, right, each one of the arrays, execute the operation, store the value in results. All right, so now that we've done that, let's go ahead and set up another loop to print out the results. Now in this case, what I want to do is just go through that results array. And I'm using just that one array in this case, so this is a great time to use the for each statement, right? So I'll just say for double the result, colon, and then I'll just say results. And I can update this print statement down here to use the result. And if I want to get fancy, I can go ahead and make this guy a block statement. And maybe I'll print out something like result equals. All right, so we have that all set. So let's go ahead and run it and make sure it works. And we go through and we get our values out, right? And so we've got our values of 2.0, 117, 208, and 33. And if I go up here, 100 divided by 50 is 2. 25 added to 92 is 117. 225 minus 17 is 208. And 11 times 3 is 33. So it works just fine. So now let's go in here and take a look where we have this if statement. Right? We have this big if else here. This is a perfect example of a good time to use the switch statement, where we're checking opcode sub I each time. Exactly what switch is meant for. And what I'm going to switch on is opcode sub I. I'm going to put the brackets at the end of the switch. I'm going to put it down here at the end of this else. we got a lot of errors shown up here, but we'll go ahead and clean that up. So what I want to do here is now is that in each one of these ifs, that becomes a case statement, right? So here for A, I'm just going to make this case. Jump to the end, take that last parenthesis, make that a colon. Right? Do the same thing for S, as well as D and M. And then where we have our else here, we're going to go ahead and make that a default. Now we end up with an extra bracket here because that's left over from the old else block that was here. So we'll take that off. All right, so now we have this set up to use a switch statement. Right? So we come through and opcodes, we check opcode sub I, and then we say case, well, if it's A, do the add, case S, do subtract, D is divide, of course, M is multiply. If they don't match up, we print out our error message and set results to 0. Let's go ahead and run this. And notice what happens. Right? We see that error message, invalid opcode for each time, and result is set to 0 each time. Right? That's because we're falling through our case statements. Right? Remember that once there's a match, it then runs all the statements after it. Right? So in the case of when the A matched, it ran the proper instruction of adding them, but then it dropped down through the S and ran the subtraction, dropped down through the D, ran the divide, dropped down through the M, ran the multiply, and then dropped down through the default and printed the error message. So what we need to do here is go into each one of these and add a break statement. So we now have our break statement for all the cases. And let's scroll down and let's go ahead from just a good style standpoint and add a break to the default as well. Right, so now when we go ahead and run this, we get the right answers again. Right, because the break made sure we only ran the code we wanted to run and then broke out of the switch statement. And so now we have our application enhanced quite a bit here. We can process multiple values. It's much more readable with the case statement. So we're definitely moving forward and making this a much richer application.